Now we move on to the golden standard of diversity combining, which is maximal ratio combining. So you can tell from the name, it gives you the maximum performance in diversity combining, right? So let's say that you have n branches here. What you do is that you apply some kind of processing. Say that, okay, I want to combine them, right? I want to multiply each branch with some complex value and then add them together. So it's a kind of linear processing, right? So here is that the question is that, given that I know the channel gain, which is R sub I, so this is the attenuation and the phase shift. So somehow I estimate those values and I don't know, and I know them. So what is the best weight, or what's the optimal weight that I should choose to get the best performance? So this is the main idea or philosophy of the MRC. Okay, so here again we need to maximize the SNR. So the SNR is actually what? When you multiply by alpha, you actually multiply the signal and the noise. So alpha appears here in the noise. So this, again, this is the SNR, and I want to maximize the SNR with respect to the alphas. Remember, alpha is a complex quantity, so it has a gain and phase, magnitude or phase, right? So using the Cauchy-Schwarz inequality, we get that the optimal alpha is actually the conjugate of the channel gain, meaning it is the same gain with a negative delay. So if we get this, right, if we get this value, we'll get the best here, the best output that will give you the maximum SNR, which is what? Which is this, right? So when using MRC, gamma becomes this 1 over n node, which is the noise spectral density, and you sum the RI's squares. So actually you sum the SNRs. So this is an important result. So the output SNR for the MRC is actually the sum of all of the SNRs coming from all the branches. So here you are efficiently using actually the available data and available power, right? Okay, so what about the distribution of the output or combined SNR? As you expect, it's a bit complicated. It's chi-squared distribution with 2m degrees of freedom. So you have m branches, you get 2m degrees of freedom. So this is the distribution of it, right? The general form. And if you want to compute the outage probability, you find a CDF, which is equation 17. It's not very simple, right? But we can find some special cases for the chi-squared distribution.